Large Hadron Collider is the world's biggest atom smasher.
The Large Hadron Collider, LHC, is the world's biggest atom smasher. It's possible that CERN has found something so amazing that it changes everything we thought we knew. This famous center has been at the center of important research since the 1950s, but it has always been on the edge of what scientists know. What does this shocking find mean for us? Let's learn more about this shocking story. Putting the universe's secrets on display, the Large Hadron Collider is one of CERN's most known projects. It is the biggest particle generator in the world, with a loop over 27 kilometers long and costing more than $4.5 billion. A lot of people say this money was well spent because the LHC has led to some of the most important finds in the past few years, like finding the Higgs boson and other particles that were not known before. Over 11,000 laps per second. This huge machine can speed up different particles around its loop until they are almost moving at the speed of light. This is possible because of very strong electromagnets inside the accelerator that create a magnetic field that is over 1,000 times stronger than the Earth's magnetic field. Some people were concerned that making such a strong magnetic field could harm devices in the area and even the magnetic fields of the Earth. When these particles hit their top speed, which is 99.91% of the speed of light, they are made to crash into each other. These powerful crashes release a lot of energy in different particles. Particle showers are made when particles hit each other and spread in all directions. They only last for a few hundredths of a second before they disappear. With different kinds of particles, scientists can find brand new particles in these bursts around the impact sites. Ultra-sensitive monitors are put in place to record all the information from each one. These studies have yielded a huge amount of information that helps us learn more about the basic parts of the world. The work being done at CERN keeps pushing the limits of what we know, making us question what we think we know about the physical world, and leading to the creation of new tools and ideas. The most surprising thing is how much we still don't know about the world. A lot of people work at the Large Hadron Collider, which is where scientists from all over the world gather a lot of information from interactions between very small particles. Scientists carefully look over the more than 15 petabytes of raw data that these tests make every year. It was a big deal for the LHC when it stored more than 200 petabytes of data on its tape banks in 2017. To give you an idea, a petabyte is the same as 250,000 films. Scientists always look through data for anything out of the ordinary. A strange thing was recently seen with a particle type known as the beauty quark. There are different kinds of quarks, which are the building blocks of everything according to the Standard Model, which is a way of thinking about how basic particles behave. The beauty quark should break down into lighter particles called leptons, which could be an electron or muon, but the LHC data showed something strange. Beauty quarks were turning into muons 70 times more often than they were turning into electrons. This should normally happen about half as often as it does now. Some scientists think there might be new physics beyond the Standard Model because of this strange ratio. It suggests there might be a new type of particle involved. Finding a new particle could change how we think about physics and give us answers to many questions that we still don't have. There are 4 basic forces, but the Standard Model only talks about 3 of them: the electromagnetic, strong, and weak forces. It doesn't talk about gravity or dark matter, which makes up most of the universe. This strange thing about the beauty quark could lead to important finds. It could reveal physics we don't fully understand and change the way we think about how the world works. Scientists are still very interested in finding this new particle and learning about the forces it might reveal. This search holds the promise of giving them greater insights into the mysteries of the universe. New results from the LHC make us question what we thought we knew about particles and new lethal forces. With the LHC, the strange event makes scientists think that what they think they know might not be full, which leads them to look for new ideas. A few months ago, the Large Hadron Collider found data that didn't follow the normal rules of particle physics. Sometimes different effects happen, and that's okay, but experts paid a lot of attention to this case. They are now paying close attention to this odd result to figure out what it means. People are excited about Z prime, a possible new particle we haven't seen before because it's so weak. It might be a new type of power. Scientists believe that this force may work with electrons and muons in a way that is different from how other forces do things. It could change a lot if they keep this new force. They have been looking for years for clues to help them figure out big puzzles of the world, like what dark matter is and what the Higgs boson's real job is. Some people even think this new force could help bring together all of nature's basic forces, which is one of the main goals of physics. It would be great if Z prime were real, because it would help us understand and answer some of the most important questions about the world. The study that is going on at CERN could help us understand everything around us in a whole new way. An interesting experiment at the Large Hadron Collider, LHC, makes particles move at 91 times the speed of light. These particles are sent in different directions, and when they meet, they hit each other very hard. This clash isn't just a cool science trick. It also makes a lot of new particles and a lot of energy. When these particles hit each other, they scatter in all directions. However, they only stay spread out for a short time before most of them disappear. There are very sensitive monitors right where these tests take place. It is the job of these devices to pick up every detail from these quick encounters. They are carefully put around the collision points. A huge amount of information is being gathered. A lot of data is sent to the LHC every year, more than 15 petabytes. Researchers spend a huge amount of time going through this huge amount of data very carefully in order to deal with and study it. The LHC had saved more than 200 petabytes of data in its big tape libraries by 2017. Just to give you an idea, a petabyte can hold around 250,000 movies. They may ask you why they gather so much information. The action of a certain type of quark called the beauty quark is one of the many interesting things that have been found. A quark is the building block of matter. There are different kinds of quarks, and each has its own qualities. These types can change quickly and almost instantly become other particles. It only takes a trillionth of a second for the beauty quark to change, but recently, it did some strange things that scientists didn't expect it to do. Current ideas say that when beauty quarks change, they should each become an equal number of leptons, which are lighter particles like electrons or muons. At the LHC, beauty quarks change into muons 70% of the time, which is a lot more often than into electrons. This strange discovery makes scientists think that these changes might be caused by an unknown particle, which could mean that there is new physics we haven't found yet. This could mean a new particle with a power we don't understand. This could change what we know and make the Standard Model, which is the main scheme of particle physics, bigger. The Standard Model is a good way to understand particle physics, but it's not perfect. These strange changes in quarks bring up big questions that make the model less full. There may be new basic forces or particles about to be found. The ongoing work at the LHC is not only studying the depths of particle physics, but it could also change how we think about the basic forces and structures of the world. Let us now look at how these new findings might affect our main theory of physics, the search for the elusive Z prime particle. The Standard Model of particle physics talks about three basic forces: the weak, the strong, and the electromagnetic. It doesn't explain gravity or dark matter, though, which is what most of the world is made of. Scientists recently found something strange in their tests that didn't go as planned. Because the Large Hadron Collider, LHC, has so much data, it often gives experts results they didn't expect. This one in particular caught their attention and led to more study. Scientists think that this strange event could point to a new fundamental force and a new particle, which could be named Z prime. This particle might carry force, but it is thought to be very weak, which is why no one has seen it before. Some people think that Z prime might interact with electrons and muons in a way that is different from how known particles do. However, it is still not clear how it fits in with the other particles in the Standard Model. It would be a huge step forward in physics to find a new particle that can carry force. Some of the big questions about the world that it could help answer are those about dark matter and the Higgs boson. Some experts even think this could help bring the basic forces together, which is a goal that has been worked on for more than 100 years. A particle collider called the Large Hadron Collider was built by CERN from 1998 to 2008. Elon Musk praised their work on it. Over 10,000 scientists from over 100 countries worked on this huge project with hundreds of organizations. The collider is about 175 meters below the ground in a 27-kilometer tunnel on the border between France and Switzerland, close to Geneva. The LHC has broken energy records since it started running. The first collision reached 3.5 electron volts per beam, which was almost 4 times the previous world record. It was later made better so that each beam could hit 6.5 electron volts. Musk said that the LHC can speed up both proton beams and lead-ion beams, though proton beams are the most common type. The LHC tries collisions between protons and lead ions once a year for about a month to look into different particle physics ideas. These ongoing tests are very important for learning about the basic building blocks and forces of our world. That's not all the fun there is to it. People all over the world who study physics are interested in the Higgs boson, which is often just called the Higgs. This very small particle is connected to the Higgs field and stands for the energy that comes from it, like waves in the ocean. It's different from other particles because it doesn't behave like basic particles or particles that carry forces, like electromagnetic fields or nuclear reactions. Scientists have been working at the Large Hadron Collider at CERN, which is the world's biggest particle collider, to try to figure out what the Higgs boson is. It is here that very fast particles crash into each other, making new particles like the Higgs and exposing them. When scientists found the Higgs boson on July 4, 2012, they were very proud of their big accomplishment. They mostly found it by watching it break down into 2 types of particles, photons and Z-bosons. Z-bosons are particles that are involved in weak interactions. The story didn't end here, though. When the Higgs boson was found, it led to new questions in the field of particle physics. Experiments at the LHC, especially those by the ATLAS and CMS teams, have been learning more about the Higgs boson. The closed high luminosity upgrade of the LHC in 2029 will make this study a lot more useful. This update will make it easier to find rare events that current theories might not fully explain. It will do this by increasing the number of particle collisions. Next, we'll look at how these new ideas affect studies that are still going on at CERN. CERN's quest for 15 million Higgs bosons. CERN thinks that they will be able to make 15 million Higgs bosons every year after the update, up from 3 million in 2017. This rise might help find different kinds of Higgs bosons. Some ideas say there could be up to 5 types, with some showing up less often than others. That being said, scientists already had strong proof for a type called the magnetic Higgs boson before these improvements. The trip doesn't end there, though. Scientists think that studying the Higgs boson will help them figure out more about the world. Every experiment adds a new piece to the puzzle, and the big discoveries that come from them could help us understand the basic forces and particles that make up everything. Scientists are getting more and more excited because they are about to make new discoveries that will lead to scientific progress and a better understanding of the world around us. The Higgs field was a very important thought right after the world started because it changed the way space and time are organized. This field is what makes matter behave the way it does and gives particles their mass. Space would be empty without the Higgs field and the Higgs boson. There would be no atoms, stars, or life. The media mostly gave the Higgs boson the name God particle after it was discovered. The dramatic name comes from how hard it was to find and how important it was for our knowledge of the universe. This new understanding of the Higgs boson could be key to unlocking deeper mysteries in the universe. As scientists continue their research, they believe that understanding the Higgs field could help them solve one of the greatest puzzles in physics, the mystery of dark matter. Dark matter makes up a significant portion of the universe's mass, but we still don't know what it is. By examining the Higgs boson and its interactions, researchers may find clues that lead to the discovery of dark matter particles or forces. Furthermore, as the LHC improves its capabilities, the possibility of discovering other fundamental particles or forces becomes more realistic. With its high luminosity upgrade, researchers are poised to make breakthroughs that could challenge our current theories and deepen our understanding of how the universe works at the most fundamental level. The findings at CERN may eventually provide a more complete and unified theory of physics, one that brings together gravity, dark matter, and the other forces of nature in a single framework. The search for new particles and forces doesn't stop with the Higgs boson. The potential discovery of the Z-prime particle, a hypothetical new force carrier, could revolutionize our understanding of particle physics. If Z-prime exists, it would introduce a new force that interacts differently with known particles, perhaps providing new insights into the forces that govern the universe. As the research at CERN progresses, it also encourages a shift in how we think about science as a whole. The boundaries between theoretical predictions and experimental discoveries are increasingly blurry, and the rapid advancements in particle physics make it clear that the universe may be much more complex than we ever imagined. The LHC serves as a powerful reminder of how scientific inquiry continually reshapes our understanding of the world around us, and how every new discovery builds upon the work of those who came before. The road ahead is filled with exciting possibilities, with new particles, forces, and concepts just waiting to be uncovered. As scientists continue to push the limits of human knowledge, the discoveries made at CERN could one day lead to breakthroughs that transform not just physics, but our entire understanding of the cosmos. The LHC, with its unmatched capabilities and ongoing experiments, is at the heart of this journey, shaping the future of science and humanity's exploration of the universe. As these experiments unfold, the LHC's ability to create conditions similar to those just after the Big Bang offers scientists a unique opportunity to explore the origins of the universe. By studying the particles and forces that existed in those early moments, researchers hope to unravel the mysteries of the universe's formation, providing insights into how galaxies, stars, and even life itself came to be. In addition to its impact on fundamental physics, the work done at CERN also has far-reaching implications for technology and society. The advancements in particle detectors, computing, and data analysis pioneered by the LHC have already been applied to fields ranging from medicine to cybersecurity. For example, the development of the World Wide Web at CERN has revolutionized communication, while particle imaging techniques are helping doctors diagnose diseases more effectively. As we continue to explore the unknown, the potential for new applications and discoveries only grows. The search for new particles and forces may lead to unforeseen technologies that could radically change industries and improve the quality of life for people around the world. This is the beauty of scientific exploration. The pursuit of knowledge for its own sake often leads to innovations that benefit society in ways we can't yet predict. While CERN's work has sparked some controversy and curiosity among the public, the scientific community remains focused on its ultimate goals. The excitement surrounding the LHC is not just about uncovering the secrets of the universe. It's about the ongoing pursuit of knowledge that pushes the boundaries of human understanding. Every new discovery opens doors to even bigger questions, and each step forward brings us closer to a more complete picture of the universe. In conclusion, CERN's research at the Large Hadron Collider is more than just a quest for new particles. It is a journey that challenges our understanding of everything, from the nature of matter to the very fabric of space and time. As the experiments continue and the data pours in, the discoveries that emerge will not only shape the future of physics, but will also have a lasting impact on our world in ways we can only begin to imagine. The work being done at CERN is a testament to human curiosity and the drive to understand the cosmos, no matter how complex or mysterious it may be.